Alright, how's it going, y'all? Today we're going to be going over the 15 most common reasons, in my experience, why a Synology is slow when it comes to file transfers. And so this is when you're dumping files to your NAS and they're just not writing that quickly, or when you're trying to get files from your NAS to your computer and it's just kind of slow. And so this list really comes from my own experience. I do a lot of Synology consulting. I do a ton on Synology, obviously, with this channel and looking through forums and everything like that. And so this list all comes from my experience. And so I'm going to be breaking up this list into 3 distinct sections based off what is the slowdown. And I'm also going to be going over some of the ways to speed them up or at least diagnose the problem so you understand it better. And so the first section is based off of network. And that is by far the most common, where it is really most common whenever a Synology is being slow, it is due to the network for some reason. The second most common one is the disks, the actual disks in the Synology. And then finally, the third section is based off of the actual Synology itself, which is basically the hardware within the Synology being slow / the operating system. And I've got a few of those as well. And so before we get into the list, I did want to go over how to get a clean baseline for how your Synology is performing, so you can actually start figuring out how fast it is and see if it's you or if it's your Synology. And so this will be helpful. And so what I would recommend doing is go to your home network and mount the Synology as an SMB share. You can do this on both Windows and Mac OS, and I've got a video for both those that I'll leave in the description. Then if you're on Windows, you're going to go ahead and download a program called Crystal Disk Benchmark. And if you're on Mac, you're going to go ahead and download Blackmagic Speed Test from the App Store. And these are the 2 most common ways to test the throughput of a disk, or in this case, an SMB share. And this is actually just going to give us the max sequential read and write speed, but for most users, that is actually how it feels fast or slow. Most people are only going to notice when it's slow if they're transferring large files over the network versus if it's not great in high-performing IOPS. Most people do not have super high IOPS except for video editors. And video editors still need sequential reads to be able to stream all those video files across the network and make sure that the timeline is not jittery when you're playing back. And so it's not a perfect test, but it is a good baseline that I would say encompasses most people. And so I'm on a Mac, and you can see right here, I've already mounted my SMB share. And so I'm just going to go ahead and select Target Drive, select it and click Open, and just go ahead and click Run. And we're going to see what the metrics are and see how fast it's writing and reading from that drive. And so you can go ahead and do this, and it's a great way to kind of get a clean performance out of it. It is not perfect. It is not necessarily a full scientific study, but it does give you numbers, and you can start to see how things are affecting your performance in terms of a raw throughput. And so this is what I use, and then on PC, it's very similar, Crystal Disk Benchmark. All right, and so now that you've got a way to gauge your performance, we can go ahead and go down this list. All right, and so we're going to be starting with the first category, which is your network being slow. And the very first part of that is the fact that you are on Wi-Fi. By far the most common issue with a slow NAS and a slow file transfer is because you're on Wi-Fi. Your router might say it can transfer at 2.8 gigabit. That is just not true. You're never going to see those numbers. That is basically the aggregation of multiple Wi-Fi antennas and multiple different protocols. You are not going to see that, and it is just not obtainable. Wi-Fi speeds are just not going to get you dependable performance if you need that. I'm not saying they're bad, but if you're looking to figure out why your transfers are slow and you're on Wi-Fi, it's probably because you're on Wi-Fi. A simple test of this is move closer to your Wi-Fi router. If it speeds up, it's your Wi-Fi network. And that's just what it is. Wi-Fi 6 is going to help a little bit, but it's still not going to solve the problem. With packets dropping, with your range really causing a lot of slowdown, I can get 70 megabytes per second read and write if I'm close to my Wi-Fi router, as in about 10 feet line of sight away from it. But if I step even one wall over, it can drop down to 30 megabytes per second. And if I'm upstairs, it can be 5 megabytes per second. It is just so unreliable. And so with your expected performance with this, I would say you could be anywhere from, well, realistically, honestly, 1 megabyte per second if you're kind of out of range, up to maybe 70 megabytes per second is about the best I've ever been able to get. You might be able to get a little bit more than that, but quite frankly, that's only when you're right next to the router and everything is perfect. Another thing you need to check is even if you've just plugged in an Ethernet cable, you need to make sure you're actually using that and not the Wi-Fi still. So on a Mac, and I believe it's the same on a PC, if you go ahead and you're mounted a share over Wi-Fi and you plug in an Ethernet cable, it is not going to unmount from the Wi-Fi and mount from the Ethernet cable unless you force it to. It will have any new connections go on the Ethernet cable, but until you disconnect from that share and reconnect, it will keep using the Wi-Fi because it's not going to remove that from the protocol. A common way to fix this is to turn Wi-Fi off and turn it back on, but that is just one thing to remember, and it's something that's caused me issues before. All right, and so the second most common one is you're just saturating your network connection. A gigabit connection is fast when it comes to Ethernet, but in terms of transfer speeds, it's not that fast. A 1 gigabit connection optimally will give you 125 megabytes per second read and write. That's because gigabit is measured in bits, where file transfers are measured in bytes generally. And every 1 byte is 8 bits. And so you divide your bit connection, so 1 gigabit divided by 8 is 125 megabytes per second. And so that's often why people get confused why they're not getting 1 gigabyte per second, is because they're getting 1 gigabit per second. And so that is honestly not that fast. And so a 1 gig connection is easily saturated in most cases, and unless you upgrade to a 10 gig connection, you're really not going to be able to get better performance out of it. Then if you go up to 10 gigabit, it's a lot harder to saturate it, and so you'll probably get around 1 gigabyte per second, maybe 1.1 gigabytes per second, because there's just a lot more overhead and all that transferring is a lot more difficult. And so those are your basic theoretical numbers, and really the only way to increase that is to increase your network protocol, or in special circumstances where there are multiple people connected on your network, you can use what's called link aggregation, but that is only going to help you if you're fighting for bandwidth between another user at identical times. Another thing to check for that I've actually seen is actually somebody had a 100 megabit switch in between their NAS and where they were connecting. And so with networking, you are as slow as your slowest protocol in between. And so you only would be getting 100 megabit speeds rather than gigabit speeds. So that's something to check for. Number 3 is you're doing link aggregation and expecting to get better single user performance. You are not going to get better single user performance with link aggregation because it only is increasing the number of pipes. It is not actually increasing the bandwidth of a single pipe. And so you're only going to be able to use one of those pipes at a time per user. If you have multiple people on your network, all connecting at once, all transferring files at once, having multiple pipes, i.e. link aggregation, can speed things up, but single users will not see any performance increase using link aggregation. It's good for failover, but you're not going to see any real performance increase whatsoever. And so another thing, you might see some tutorials online about a thing called SMB multi-channel. SMB multi-channel is a Windows protocol that allows SMB to go over multiple link aggregated connections. Meaning if you have 4 gigabit connections, it can transfer a single computer to a single computer at 4 gigabit. This is a protocol that is very much still in alpha when it comes to Samba. It is enabled for testing and testing only. Do not enable this on a NAS where you expect to keep your files non-corrupted. It can cause file corruption due to packet mismatch, and all of your data can be completely rendered useless by this. It is only for testing. They are working on adding it in, but until they do not try to add it in because it will only cause you issues and it can have silent file corruption. It is not worth trying to enable. Do not follow those tutorials unless you're just messing around on a test bench and you want to see what happens. All right, and so now reasons 4 and 5 are actually both jumbo frames. 4 is you do not have them enabled, and 5 is you've got them enabled, but they should not be enabled. So jumbo frames are a lifesaver for 10 gigabit connections. You're really not going to see any performance increase, and you should not have them on for gigabit connections. But for 10 gigabit connections, they turn my 300 megabytes per second connection into a gigabyte per second connection, all by just increasing my MTU from the standard 1500 to 9000. Essentially what they allow you to do is cram more data into every network packet, and that means that there are fewer network packets to transfer, which means your switch and your network cards have a lot less overhead to process. And so it can really increase your performance because of that, especially if you have a cheaper network card or cheaper 10 gig switch. The thing is, they are in no way part of the official Ethernet standard. A lot of manufacturers have implemented them, but since it's not part of the standard, everybody kind of did it their own way, and some people just did not. Therefore, you need to make sure that every single switch, card, everything your packets go through has jumbo frames enabled and is on the same MTU or greater. And so if they're not, you'll run into an issue called packet segmentation, where a device is unable to process the full jumbo frame packet, which is larger, and can only process a small regular size packet. It therefore has to do extra processing power to chop up that packet into smaller pieces and then send it over. And that causes a huge bottleneck when it comes to your switch or whatever is having to do that chopping up. And so that's why number 5 is jumbo frames are enabled, but they are not supported. And so you need to make sure everything that the packet goes through has jumbo frames enabled, and even then you might have some issues. One way to diagnose this is to turn jumbo frames off and see if you get better performance, and also possibly turn down your jumbo frames from 9,000 to 8,000 just to see if anybody else has enabled jumbo frames but has in a slightly different manner. And that way, if a manufacturer has a different definition of what a jumbo frame is, it'll hopefully still not get chopped up using packet segmentation. And so that is one way to diagnose that and still get good performance with jumbo frames just using a smaller MTU. But for users with 10 gigabit connections who are not seeing that full throughput, that is a great place to start, is enabling jumbo frames, because it can give you a huge performance increase. Just make sure everything supports it. All right, and so now 6 and 7 is SMB issues. So number 6 is you are using SMB version 1, aka CIFS. So SMB version 1 is a lot slower than its preceding versions and can really slow you down, especially on 10 gigabit connections. So I would really recommend turning off SMB1 if at all possible and forcing at least SMB2 connections. To do that, you just go into Control Panel, File Services, SMB, Advanced Settings, and then say Minimum SMB Protocol SMB2. And it might cause issues with you, but if you can enable that, that will mean that everybody's at least talking SMB2. Almost all protocols default to SMB2 at least, normally SMB3. But another thing is, if you're mounting a Mac, make sure to type SMB:/ rather than CIFS://. And so that is one thing I've found that really slows things down. And so now issue number 7, it's not as common as it was a few years ago, but you've got signed SMB packets turned on. Basically, this means that your SMB packets are being encrypted. SMB encryption is incredibly slow and really slows down a network, especially over 10 gigabit speeds. And older versions of macOS decided to turn this on by default, and it really slowed down SMB performance. If you've updated your macOS version, you should not have this problem. But if you've got an older version of macOS, there is a terminal command that you can easily look up, and I'll leave an article to how to do it in the description below, onto how to disable signed SMB packets. You can also go into transport encryption mode and make sure that it is on disable. And that will also say, hey, no, you're not allowed to try to encrypt SMB packets. And that way you do not run into that performance bottleneck. SMB is not a protocol meant for the internet. It is meant for a trusted inter-network. And so having them encrypted is just going to cause you a huge slowdown. And if you're accessing them over the internet, you need to be using a VPN or a different protocol, as SMB is not for the internet. All right, and so now we're through the network issues. Now we're on to the disks that are in your Synology. And number 8 is you just have too few disks. This is most common with 10 gigabit connections, as basically any one disk should be able to saturate a 1 gigabit connection by itself. So this is really only for those 10 gigabit connections, or if you've got multiple users. And so the way RAID and SHR work, and for this I'm going to use RAID and SHR interchangeably, because in this case they very much are. Basically, the more disks you add into an array, the more disks are able to be read and written from at the same time. Other than RAID 1, but that's a special circumstance. And so the more disks you have, the faster your drives will be. And so the way I always estimate this speed is I say every disk has about 200 megabytes per second read and write. It's a little bit lower than that generally, but 200 is a good easy number to guess around with, and it will get you in the ballpark. Then you calculate how many disks are used for parity. And so if you're RAID 5 or SHR1, that's 1 disk. SHR2 or RAID 6, that's 2 disks. RAID 10, RAID 1, very different circumstances. They're going to have their own calculations. But what you do is you go through and subtract the number of disks used for parity from the total writable pool. And so if you have 6 disks in an SHR1 configuration, that means you have 5 disks that can be written to simultaneously, and that 6th one is used for parity math. And you're also going to have 5 to read back from at the same time. And so then you say, okay, every single disk is going to give me about 200 megabytes per second at best. And so that means that 5 disks times 200 megabytes per second will give you about 1 gigabyte per second as your theoretical max read and write speed from that pool. The parity math used in both SHR and RAID will take a little bit more of that down, but 200 megabytes per second tends to be a good starting point for estimating this. And so that's a good way to test. If you've only got 4 disks in SHR2, you're going to have a lot of trouble saturating a 10 gig connection because you're only going to have about 400 megabytes per second to read and write from. And so that is a reason why people do have slower things. Luckily with Synology, if you have extra bays, you can just expand that out and it will speed up your pool significantly. Another one that I want to throw in there is SMR drives. There are a few SMR drives out there that are branded for NAS. Currently it's just WD Red, the standard ones under like 4 terabytes. I've not done a great job of figuring out exactly which units have SMR, but you want to avoid SMR in any NAS you've got just because it's going to slow you down a ton. Synology does not seem to have the same issue as TrueNAS does when it comes to crashing upon a rebuild. ZFS, which is the file system of TrueNAS/FreeNAS, when it encounters an SMR drive, because of the issues with that drive upon a rebuild, it can take months to rebuild the pool because it is so slow. And so I would recommend searching and making sure whatever drives you're buying are CMR drives because they will just not cause you headaches. And a few programs have been set up where you can contact the manufacturer and say, hey, you sent me SMR drives for a NAS, I want CMR drives. And so people have done that. I'm not going to go into that in super depth here. I probably need to do a video on it, but if possible, avoid SMR drives. Number 9 is when your disks is slow or failing. So I've actually had a couple circumstances where somebody bought 6 really nice NAS drives and then said, oh, I've got this cheap external drive, I'll just shuck it and throw it in there as a 7th drive. The thing is, with RAID and SHR, you are as fast as your slowest disk because everything has to be read and written from at the same time in parallel. So if you have one slow disk, your entire pool is going to operate at the speed of that one slow disk. So every single disk you have will be going at 100 megabytes per second if your slowest disk can only go at 100 megabytes per second. And so don't just throw in any random drive into your pool because it can really slow you down. If you have all the same disks, this can actually be a really good sign of failing drive. And so the way you test this is you go through and you start off a disk test, just like I've got here. And then we're going to go into your NAS and go into Resource Monitor. You can then go through and click on Disks, View All, and these all should basically have the same utilization amount. See how they're all roughly the same? That means they're all working at the same and not one of them is overworked as the other ones. And so if one of these was like 90 plus, that would mean it was probably one that was failing or was a bad disk compared to the other ones. And so what you want to do is you want to back up all your crucial data and replace that drive because it will really help speed up your pool. This is another way of telling if it's your disks or if it's your protocol is by hitting off a test and seeing what your total volume utilization is. If this is above like 80 probably, that's about where I'd say, okay, you're being limited by your disks, and then anything under that is most likely being limited by something else. And so now number 10, you have a write cache enabled. So SSD write caches are something I really do not recommend for a few different reasons, and this is one of them. And so SSD caching can give you massive performance increase. And so I've seen this. I was able to saturate 2 10 gigabit connections in link aggregation just using the SSD cache as the pool I'm reading from. And so it has these huge performance increases. But the thing is, NVMe drives and regular SATA SSDs as well are not ultra fast to write to throughout their entire storage area. Generally what they do to speed up everything is they've got about a 20 to 40% size of the entire drive is reserved for this super fast writable area. And it's kind of its own write cache. And so any data you write to the drive will be first written to there because it'll send your entire controller going really fast and everything will go great. But if you're transferring a massive amount of data, that will start to fill up. And once that fills up, you can get so slow performance out of them because they've got to go through and they've got to clean up all that data while they're still accepting new data. I've seen this where I've got performance that dipped from a gigabit per second all the way down to 200 megabytes per second because the cache was just being hit too hard and there was too much data being written to it. And so that's one of the many reasons I would not recommend having a write cache, because they can start to fill up and slow down your entire pool. Generally, when you're writing data sequentially, which is something that hard drives are really good at doing, especially in a RAID. So if you have 6 drives in a RAID 5 array, they will be able to write data at about a gigabyte per second. And so by having that SSD cache in there that's first getting written to for all that data, you can run into a bottleneck there where you just don't need one. Read caches do not have this issue because reading back from anywhere on the SSD is ultra fast, and you actually get twice the storage. And so really that's why I would highly recommend going for a read-only SSD cache, because it's just going to give you a lot better performance across the board. And there are very few users who are going to get any appreciable performance increase from having read-write. And in my experience, it's probably going to slow you down before it's going to speed you up with my testing. And so a pretty easy way to test this is go ahead and transfer like a 100 gig file, a huge file to your NAS. And if it's going super fast until about maybe 50 gigabytes in, and then it starts to slow down for some reason, it's almost certainly because you have that read cache and you're hitting the full internal cache of the NVMe drives. And so that's one thing to look out for and can really cause you to slow down overall. You can still use the drives, just set it up in a read-only cache and you will have a much better time, I promise. Now on to 11 is your disks are full or need to be defragmented. So full disks have very little area that's actually writable to them, and so it can take a very long time to write data to them. This is anything over about 80% probably is when you really start to notice a performance decrease because there's just not sections of data that can be easily written to. So another side of this is defragmentation, and that's where you've got a bunch of data that's been written, deleted, written, deleted, written, deleted to the NAS, especially when it comes to small files. By doing this over and over and over again, your disks end up with these small packets of empty storage where they have to split up large files into tiny chunks to write them all over the disk. So the way to solve this is called a defragmentation. It does not play great with BTRFS snapshots, so if you do need to do this, go ahead and delete any snapshots if you can, and that way they won't balloon in size. I found that BTRFS snapshots can go up by about 10% in the worst case. And so make sure to delete your snapshots beforehand and then do a defragmentation. And then you can re-enable snapshots and it'll be like nothing ever happened. Generally, you do not need to do a defragmentation, but maybe once a year. And that's only for people who have written a ton of data, deleted a ton of data, written a ton of data. And I'm talking, when I say a ton, I'm saying like 2 or 3 times the entire storage volume of your NAS. And so 12 is our last section for disks. And this is a very special circumstance that occurs with SHR and multiple disk sizes, which is also the reason why SHR is not available on the enterprise NAS units from Synology. So SHR is great because it allows you to get more storage out of mixed drives than regular RAID. And so in the circumstance where you've got 6 4 terabyte drives and 2 8 terabyte drives, standard RAID would just count all 8 drives as 4 terabyte drives, and you would lose basically 8 terabytes of storage that would just be gone. Instead, SHR will do something a lot more efficiently. It will still do the exact same thing as RAID. It will start by assuming all the disks are 4 terabytes and creating a RAID across all 8 of them, basically assuming they're all 4 terabytes. But then with that wasted space, it'll create another RAID volume in there. It'll say, okay, there's now 2 4 terabyte sections that we can use off of those 8 terabyte drives. And it will create a RAID 1 array between those two, or a RAID 5 array if there's 3 of them or more. And so what it'll do is it'll actually use that extra space and create another RAID volume. And so it'll use that as total usable space for the volume. And so this is great. You now get an extra 4 terabytes in this circumstance, and you're not wasting that space. However, if you think about it, those 4 terabytes only can be written to 2 disks, but in reality it's 1 disk of speed because the other one's used for parity. And so if you're writing that very specific 4 terabyte section in this case, you will actually get about 200 megabytes per second read and write from it, because you're only being able to write to that one small section, and it doesn't have a lot of disks to expand outward and get better performance out of. And so that is actually why it's not part of the enterprise users, but it is a very special circumstance. And if you don't have mismatched disk sizes, you're not going to run into this. And it's easy to solve by just upgrading additional disks if you really need it. If you then upgraded all your disks to 8 terabytes, you would then once again have total performance across all of them. And so that is just one thing to note. And so you could see a little bit weird performance where it's great for most of the time, but then all of a sudden sometimes it drops down your performance. And so that might be why in that special circumstance. Now we're moving on to the Synology being slow. And for 13, it's your drive is encrypted, but you don't have hardware to handle it. So to encrypt data, there's a lot of math involved to do that, and that CPU has to handle that. And if the CPU is not built to do that, it's actually going to be pretty slow because there's a lot of stuff that has to happen. Most higher performing Synology units have a special encryption chip, which allows for the CPU to just say, hey, encryption, that's a special command that goes really fast. And my NAS has that encryption chipset. And so I've not been able to notice really any difference between reading and writing from an encrypted or non-encrypted pool. They were pretty much the exact same, but if you do not have dedicated encrypted hardware, you can really notice a slowdown, especially if your CPU is busy doing other things. So that is just one thing to note. Most higher performing NAS units should have the encryption, and it should not be a problem though. 14 is that you've actually got Synology Drive server as a team folder enabled on whatever shared folder you've got. I have found this in my own testing where I'm trying to do a 10 gigabit SMB transfer of a huge amount of photos from my camera to the actual volume, but I had it enabled with Synology Drive. That meant that Synology Drive was indexing all the files coming in and having to go through with photos, create previews, and also make sure that any other drives were updated in the right folders. And so it really took a hit for my performance. And so what I would recommend doing for people who want to use Synology Drive is I would recommend having your Synology Drive folder be a separate volume than your bulk storage where you need really fast read and write speeds. Most people are not going to be syncing the terabytes of files between their computer and their Synology, and so there's no reason to have the giant bulk dump data be a Synology Drive folder. Instead, have a separate volume for that, and then have your fast volume. That is just one thing I noticed when I was trying to figure out why I was having a slow transfer. And finally, 15, it's your NAS. Your NAS is just too slow or busy. Specifically, it's probably the CPU, but if you don't have a lot of RAM, or if you've got a lot of RAM dedicated to virtual machines, it might also be you're running out of RAM, and so things have to be swapped to the disk and back, really slowing down your NAS. A good way to test this is to be able to dump a ton of data to your NAS with all your services turned on, so Docker containers, VMs, everything, get a benchmark there, then turn all those services off and do the same benchmark. If the performance increases significantly, it's probably that your NAS is just too busy doing too many things. And from there's not a ton you can do. You either have to kind of turn off services, live with the performance, or upgrade your unit, because there's just really no way of solving this. A reboot might help, but in most cases, probably not. All right, well, that's it for my list. I hope you enjoyed this, and I hope this was helpful. If you want to go ahead and hire me, there's a link for that in the description. And if you want to start sponsoring the channel, there's a link for that as well. All right, have a good one. Bye.